So in this video, we're looking at 14 part B. So for BI, we want to sketch the curve C, and for BII, we want to explain briefly why C does not include all points of y equals 6 minus x minus 3 all squared, where x takes real values. So we can kind of answer these together, because if we have a look at this equation here, this is a quadratic equation in completed square form. What's great about that is we can immediately read off the minimum or maximum point of the quadratic. In this case, it's going to be 3, x equals positive 3, y equals 6. So that's going to be one of the coordinates that we're going to mark in our sketch. And this negative sign in front of the squared brackets tells us that the x squared term of our quadratic is negative. And so if it helps to think of it this way, you can think of it as an unhappy parabola. So that's a general shape. And that means that the coordinate we've read off here is going to be a maximum point. So we can mark that on our sketch immediately, as I've done there. And so we expect this curve to look like a parabola like that with a maximum point here. However, we need to be a little bit careful, because our curve C does not include all of these points, because this is for all real values of x. And our curve C, which is defined by these parametric equations, is actually constrained by the sine t and cos 2t terms. So x and y are restricted. So now we have to find those values so that we can mark them on our sketch. And so they're going to be coordinates that we can't draw past. So we can't continue drawing the parabola beyond the points that we need to find. Okay? And that is because of these terms here. So the easiest way to do that is the sine t term. That's quite easy because we know sine t takes values between 1 and -1. And so we can find the range of values of x. What will be useful is if we find the minimum x value and then the maximum. And then we can find the corresponding y values for these two x values. And then those will be the points that we mark on our sketch. So x min will equal 3 plus 2 times the value that sine t takes as a minimum, and that's obviously -1. And then for x max, it's going to be 3 plus 2 times the maximum value of sine t, which is just 1. And so x min is equal to 3 minus 2, which is just 1. And x max is 3 plus 2, which is 5. And now, to find the corresponding y values, just substitute those x values into the equation we have here. So then for the coordinate, for the x coordinate of 1, we have a y coordinate of 6 minus 1 minus 3. Okay, 1 minus 3 is -2. So -2 squared is 4. So doing 6 minus 4 is going to be 2. And then the other coordinate will be with an x value of 5. So we'd substitute 5 into here. So 5 minus 3, that's 2. So positive 2 squared, that's 4. 6 minus 4, that's 2 as well. So it's 5, 2. So these are the coordinates that we're going to mark down, and we can't draw the parabola beyond those points. So 1, 2, and 5, 2. So again, this is a rough sketch, but I'm going to mark it there. And then 5, 2 is going to be there, making sure that these are lined up because obviously they have the same y values. So now you can try to draw a smooth curve, something like that. Perhaps I'll move where I've marked the maximum point to make it look a bit better. So then that is our correct drawing for curve C. And we've explained exactly why it does not include all the points of our quadratic here, and that's because sine has a minimum and maximum value, has a range between 1 and -1, and so you're going to get a range of values for x. Okay, so you can make a note of that here. This is for part I. For II, sine t is between 1 and -1. Therefore, we get a range, say restricted range for values of x. Okay, so that's for part B. In the next video, we're going to go through part C.